This is the lesson video for 3.3. Please find this part in your notes. You're going to need to pause the video for the parts where you don't have some of the table data written in, and actually then take that moment and write the table data in before you continue with the video. And for best understanding, racing through it won't help. Put the video back a little bit and play the parts again that you need to hear in order to have this make good sense. In 3.3, we're going to pick up from the information we were doing when we were collecting data. When we collect data, we often look to see what the data is changing by. And the rate of change for tables or graphs can be calculated in one straightforward way every time. It's the change in the output values. We're going to call those y's. And the change in our input values, and we compare. And when we compare those two quantities, we end up with something that tells us about how a quantity is changing in terms of things like miles per hour, feet per second, money per minute. And that's always going to have a double label, something that the numerator label comes from and something that the denominator label comes from if the data has context, meaning if we collected it with meaning. In the first data table, pause the video if you need to write in those outputs of 6, 12, 18, 24. And when you first look at those, we want to look at the change in the y values first because that's what we actually see. What that we measured in our experiment changed. And in this data, I noticed that from 6 to 12 is an increase in 6, from 12 to 18 is also an increase of 6, and from 18 to 24. Sometimes those numbers don't come up the same, and that's okay. We can still find a rate of change on a table. We have to see what our x is doing. And in between the first two pieces of data, x increased by 1. It did the same for the next set and the following set. This table's displaying that every time the y goes up by 6, the x went up by 1. So in going back to the idea that we're looking for change in y, our change in y is right here. And then we're also looking for how x changed at the same time or in that same set of data, and our x is changed by 1. So our rate of change here is going to be 6 over 1, and we're going to simplify that to just 6. Our table didn't have meaning, so we don't need a label on that set. In the next set, again, if yours are blanked out, pause the video, fill in those distances traveled, and then come back. If you're back, that means that you're ready to actually look at how much these changed by. So from 76 to 152, that increased by 76. And the x's, or in this case h's, increased by 2. This went up 76 miles, and the time went up 2 hours. In the next set, we also increased by 76 miles, and again, that was an increase in 2 hours. So when I go to write my rate of change here, I'm going to start with my rate of change of my y's, which was 76. And that's going to go in my numerator here. So it was 76, and that was positive. And that was in miles. If they have labels, include the labels. Then I'm going to go get the change in x. And my change in x was 2. And that's going to go down below for every positive 2 hours. Then I need to reduce that so that I have it in a ratio that's simplified. And when I do, we're going to get 38, or 38 over 1, but 38 for the numerical part, and miles per hour for our denominator label. And what that's telling me is for every hour traveled, every 1 hour driving, we traveled 38 miles. 38 miles. And that's an average over those 2 hours. On the next one, let's see what we know. We went up $1 in cost. We went up $1 in cost every time the minutes used increased by 20. So our rate of change then is my change in y's, $1. And my change in x's, we don't get to change the order of that for 20 minutes. When I divide that out, I'm going to get a decimal, and that's okay. And it's going to give me 0.05. And since that's money per minute, It's telling me that that was 5 cents for every 1 minute that was used. Maybe this was a cell phone plan, maybe this was an international phone call to a country. On graphs, you did some of this last year. Now we want to look to add a little bit more. So on this airline departure graph, we want to be able to do the same thing. We want to be able to check our increase in y over our increase or decrease in x. So I'm going to take two ordered pairs. I've got that first one right here, and they're telling me that that's at 8.1 to help me out. And I'm going to see how much change in y I have first. And then when I get up to where I can see a nice place to draw over to the next data point, then I got to see about my x's, how much my y's changed and how much my x's changed. So I'm going to do the symbol that we use in math sometimes, change in y. My change in y means how much did it increase. And it was 9 when we ended, but it was 8.1 when we started. So my change in y I'm going to put as 0.9. And that change in y is millions of airline departures. So I'm going to put 0.9 million departures. That means airplanes leaving. And then in the denominator, I've got to put change in x. So I have to see where my x's were. This was 1995 to the year 2000. So 1995 to the year 2000, my change in x is that year 2000. So we don't want to do 0, 0, 0, minus 1995. Put the actual year in. And that was in 5 years. Okay, and when I divide that out, that's going to tell me an increase every year. So I don't want to leave it in the form it's in. I actually want to get it down to a single number or a reduced fraction. In this case, a single number is going to be okay. 0.18, and that's in million departures. So we had an increase in airline flights leaving every year. And 0.18, if you need just a better sense of how many that is 180,000 more airline departures each year. In the next graph over, we're talking about rides at the fair. So this could be maybe state fair, any fair that's got rides. So when I look, they've got the data labeled for me, which is wonderful. So I can actually read those ordered pairs and I can see my labels, rides and tickets. So I'm going to take any two solid data points. By solid, I mean they go through coordinates I can accurately find. So I'm going to take the 1, 3, and I'm going to take the 3, 9. You can actually take any two, but that's why I want to show you how we're doing that. And there's going to be our change in y, and there's going to be our change in x. So my change in y, it's going up to 9 tickets, but it started at 3. So 9 minus 3. This increased by 6 tickets. And my change in x, that's going to be that went from 1 ride to 3 rides. So 3 minus 1, it went up 6 tickets for every 2 extra rides I chose. So the meaning is that it's 3 tickets. I divided 6 by 2 to simplify. Per ride. Every time I want to increase 1 more ride at the fair, I've got to pay 3 more tickets. So this is telling me how 2 quantities compare over time. At the bottom of that page is an important reminder. If you count up in the y's, that means you're going positive. If you count to the right in x's between your points, that also means it's positive. If you have to count down on a graph or to the left on the graph, that means the number that goes into your rate has to be negative. And we're going to see some negative rates here soon. So you're going to pause this video, or turn this video off because there's a second one, and just catch up on notes if you need to.